So again, I'm picking just some basic problems that are in your book, and that's where I'm getting some of these examples from. So don't feel like I'm just picking random things. So the goal today, we're going to still deal with the trig functions. One of the last few days where we're doing normal trig function evaluation. We're in section, I already put the section symbol. We're in section 4.4, the trig functions. Goals today. We have a couple new things I want to cover. So one of the problems I'm going to start writing off the bat on, we're going to do a coordinate plane problem. We're going to do a coordinate plane problem, and that's one that we'll have to look at positive negatives. So that chart will definitely help us out with that. Okay, the positive negative sign chart that we did yesterday. Excuse me. So we're going to do the for the coordinate plane, we'll do the positive negative chart. Positive negative sign chart. That was one that we talked about. I want to discuss that one more time. The other thing is this will help us refresh our memories on the Pythagorean theorem. Pythagorean theorem. We have to review that. That was one of the parts that was in your homework. I think it was like the first two problems. They asked to find a missing wall of the triangle, and you can go on from there. So that was one of the problems that we need to refresh our memory. Other things we're going to talk about. We are still going to try to evaluate trig functions. So we're going to try to evaluate a trig function. Something where they give you a number and you try to find what the exact answer is. To do this correctly, this is the ones that be some of the new stuff today. We're going to take a look at the special triangles, like we did the other day. Special triangles. I know I've been bringing those up the last few days in here. I want to review those one more time. I might even put them on the board here. We have two new parts here. We're going to have this thing called the unit circle that we're going to use, which you have a picture of it, so that's kind of nice. And the second thing we're going to have is, which I'm going to just call the other unit circles. And I'm going to try to explain this the best I can. This part right here, that's all the new stuff. I know it doesn't seem like a lot. Trust me, it is. It can get kind of difficult in that range. And then we'll finish with is after we get to that stuff today, if we have a little bit of time, I want to do one quick example of a type of problem that I really like that's in your book. I really like it, hint, hint. That it kind of tests your knowledge on kind of different levels of what we're doing here. So the goal today is to do a few examples that kind of fill all the bill. And then we're gonna, it won't melt too much, just a little bit. But I like it. So, all right, let's get to the first one here. The first type of problem, it says it wants you to evaluate or find the values. So find the values. So find the values for all the trig functions. For all the trig functions. All right, now, what it's going to give you for this one? It's going to give you this. I know this can seem really weird. Negative 12, comma 5. That's all it gives you. Okay, this is really, really strange. That coordinate is drawn in a rectangular coordinate plane, right? The Cartesian coordinate system, the coordinate plane. And it wants you to draw it. So if you have, you can draw a mock sketch of the coordinate plane. So negative 12, comma 5. That'll be where the end of the triangle is going to be. So what I mean by that, if you had a normal coordinate plane on the board here. Now I'm not going to put an actual one up here and just take up too much space. But let's say we had an actual coordinate plane. Where is negative 12, comma 5 located? What quadrant?
It is in second.
Second. So it's over negative 12. So here's, let's say this is negative 12. And we're up 5.
I was going to make sine and cosine.
Okay. Sine and cosine. Sine, cosine, yeah. All right, so that's where the end of that line goes. Because how I know that, I'm drawing a line from the origin, always from the origin, directly out to where that dot is located. Now, when we draw the right triangle on this picture, which axis do we always go back to?
X.
X. That's how you do referencing this, right? We always go back to the x-axis, the closest x-axis to where your line is at. Okay? So now that we have that, this is the reference angle that we're looking at. It's always the one that's closest to the x-axis. And so when I have these numbers filled in, this number is the negative 12, this number is the 5. It's the height. And now you can do the Pythagorean theorem, find your missing wall, which it could be as radical, it's fine. I think this one will turn out to be radical because I just made up the numbers. And then we can do all the 6 trig functions, all 6 of them, all 6 main ones, which we haven't really done up to this point yet. I think one of the homework problems asked on that last assignment, I think it was like 4 and 5, asked for all the trig functions. Remember, on those problems I was really looking for, could you find the missing wall, Pythagorean theorem. I mean, that's what I was talking about. If you did set them up, that's great. I will check them. I will take a look at what you did. Because I know, like, Tori started like the first day and then get to the instructions.
It works out perfect.
Okay, all right. But let's do the math here. If we're doing the Pythagorean theorem, this is A and this is B and this is C. Now, how do I know where A, B, and C go? C has to be the hypotenuse. It's the longest wall. A and B are the 2 legs. They have to touch the 90-degree marker. I don't care if your A and B are switched. It makes no difference, as we talked about last Thursday and Friday. So this is 5 squared plus negative 12 squared. And yes, you do need to put parentheses around that if you have a weird calculator that requires it. And then that equals C squared. So if I do the math here, that's 25 plus 144 equals C squared. This adds to make 169. And when you take the square root of it,
A big old 180.
it is a perfect 13. So that was very kind of nice. Okay, I got lucky. All right. Okay, so we got 13. So I can fill the 13 on the picture. Now, I know that when some people look at that, they're like, well, Ward, you did an equation. That was an equation, and you solved for a variable. Shouldn't there be 2 answers, like positive and negative? Yeah, but the hypotenuse is the number we're finding, right? We're finding the hypotenuse. The hypotenuse should always be positive. The only numbers that could be potentially negative are the legs of your triangle. Those are the only numbers that could be negative when you set these up, so keep that in mind. The hypotenuse always has to be the positive number. Okay, because I'll come back to that rule a little bit later. All right, are we good so far with the setup, how I found that missing wall?
Yes.
Okay, now, last thing. We have to figure out the 6 trig functions. We have to find the values for all the trig functions. So if we're going to set them up, let's do the main 3 over here. So sine, cosine, and tangent. Sine of alpha, cosine of alpha, and tangent of alpha.
I like that.
And then once we have these, we'll do the reciprocal functions here in a minute. So what does sine stand for in SOHCAHTOA? Opposite over hypotenuse. So the opposite wall of my alpha.
5 divided by 13.
5 divided by 13. Now, if you're using your positive and negative chart, I think Reese, you brought it up earlier, the positive and negative chart, sine and cosecant are positive in that second quadrant. So if you're looking at the positive and negative chart, it is positive, right? So in fact, let me put that chart up here in case you were gone yesterday. Did anyone not receive that handout that I gave yesterday? Okay, just making sure. So all trig functions are positive up here. In the second quadrant, it's sine and cosecant. Then it's tangent and cotangent are in the third. Those are the ones that are positive. And then cosine and secant. Because remember, every trig function is always paired with one that has the letter C in it. Every trig pairing has one that starts with letter C. Every pair has that. So sine is opposite over hypotenuse, and yes, it should be positive because it told me that. If I'm in the second quadrant, which I am, these are the 2 that are positive. That's why that positive negative sign chart is kind of essential. It guarantees I probably did something right. The only thing I could get wrong, maybe I switched numbers back. Okay, but let's do cosine. Cosine is ka in SOHCAHTOA. So what does that mean?
Over hypotenuse.
Yeah, adjacent over hypotenuse, so that's what? Negative 12 over 13?
Yeah.
And if we're in the second quadrant, cosine should be negative. Because it's not sine or cosecant, so it should be negative in that quadrant. So that makes sense?
Negative 12.
Tangent,
Yeah.
TOA. That's what? Opposite over adjacent, so 5 over negative 12. And again, I don't care where the negative sign goes, it can go top and bottom. Doesn't really matter. But there you go. There's your main 3 trig functions. Now, to get to the other ones, the reciprocal functions, just flip them over. So, sine is matched up with cosecant. So So if we're gonna do cosecant, in fact, let me
13
abbreviate.
divided by 5.
Cosecant of alpha. Say it again.
13 divided by 5.
Yeah, 13/5. Because you just flip sign over, right? That's the parent.
Secant.
It's just a reciprocal. You flip the answer. Secant is the opposite of cosine. What is that? 13/-12. And then cotangent. -12/5. I flip those. All right, there you go. That's all 6 trig functions given my triangle and where my alpha is at. And when I look at each one, it makes sense that 4 of them are negative, 2 of them are not. Because when you look at the positive and negative sign chart, only 2 can be positive in that quadrant. I'm not going to joke. Right now, this part right here, what you're looking at, is the #1 thing people missed on the last year's test on this chapter. Chapter 4. They forgot negative signs. And I'm counting points off. They forgot all the negative signs.
Wow.
That's a lot of points being missed.
3, 4 points.
Okay, yeah, that's a lot of points being missed. Now that problem, don't get me wrong, that problem is worth a ton of points, like I think 10 or something stupid like that. But they missed almost half because they didn't put in negative signs.
Wow, all I had a mistake.
Okay, questions, comments about what to do on those problems? Now I know this is the first day we've ever seen that. We'll practice maybe one of those tomorrow again, just to make sure that you've seen it, and if you want more, we'll do more tomorrow. But today was to introduce that type of problem, so you know it. Again, it uses the positive negative sign chart, it uses the Pythagorean theorem, and it does all the trig functions. It's kind of like a perfect problem for mixing everything together. But the setup, you have to draw it in the right spot. Some people don't know how to draw the dots, and you get it all wrong. Okay, we good?
Yeah.
All right, let's do the second type now. Does anyone still need that one? All right, let's go to the next one. The next type of problem that I want to discuss today is where they're going to have you evaluate a trig function. Okay, evaluate a trig function at a certain point on a graph. So let's say we're doing something like, say we're doing the cosine of, can I borrow your chart? Cosine of, let's go 7 pi over 4.
This is nice little one.
7 pi over 4.
315 degrees.
Okay, so by looking at that, you can do a quick conversion. That's why that chart that I gave you, if you look at the unit circle, it can convert really nice angles automatically for you. Okay, so the 7 pi over 4, just like we said, if you're actually looking at that positive, or you're looking at that unit circle chart, the big circle, it tells you 7 pi over 4 is 315. So it can convert it for you, if it's a nice number. If it wasn't on the chart, take 7 pi over 4 times 180 over pi. So these would cancel, and then you'd divide these both by 4, and then you'd multiply, and you'd get 315. But that's how you do it if you didn't have it on the chart. Maybe you didn't know where it was, you didn't see it. You'd have to multiply by 180 over pi to convert it back to degrees. And now that we know that, we can now set up the triangle in that quadrant. We're in a 315 because most people don't know radians. You want to know where that would be. So we're in the 4th quadrant with 315. So 315 is going this way, and again, just a mock picture. This is 315 doing this. Okay. And we're trying to find the exact answer for cosine. The exact answer. I want to evaluate it at 315. Okay, so the first step, we have to bring my triangle back to the x-axis. So that means I have to go straight up.
45 degrees.
And you're right. The reference angle is 45. Now, how I know that, because I'm not just making it up. This number, this wall right here is 0 degrees or it's 360. So if you actually take 360, because that's going all the way around the circle, and I subtract the 315, it tells me the angle inside that triangle, the reference angle, is the 45. That's why I always tell you to bring it back to the x-axis, so you know which number to subtract it from. Okay, does that make sense how I got the 45? Okay, now it's one of the special triangles. We only have 2, and these should be on your property sheet. The 45, 45, 90 triangle is 1, 1, root 2. So we have to fill in those numbers where they need to be, and then I'll fill in the negatives after we're good here. So 45, 45, 90. So the sides opposite the 45s are 1s, and the hypotenuse is root 2. That's the 45, 45, 90 triangle. That's why I'm always trying to give you angles that work out to be those. Now, on that picture, one of those walls is negative.
The one on the right.
Yeah, the one going down. This one should be a -1. Now, if you don't want to worry about it, maybe you don't want to even think about where negatives go, that's fine. On this type of problem, you wouldn't need to, because I could fill in my answer later. I know that in the fourth quadrant, where I'm at, cosine is going to be positive. My answer is going to be positive no matter what. I don't even need to worry about negative signs. So, on the last one, I did need to worry about it because I had to draw it in the right spot. This one, they don't tell me the coordinates. So I can just fill those numbers in. Now, we're going to do cosine of 45. The cosine of 45 will give you the same answer as the cosine of 315. That's why we did that reference angle. So cosine, if you're going SOHCAHTOA, so this is the part of the SOHCAHTOA that we're using. It's the adjacent wall to 45 and the hypotenuse. So this is the adjacent wall. This is the hypotenuse wall. And here's the crazy part, it didn't even matter which angle you picked, because they've been both the adjacent. But what's my fraction? Adjacent over hypotenuse, what do I get? 1/√2. Now if you want to simplify, you wouldn't have to leave the radical on the bottom, you can put the radical on the top, and you just get rid of the radical on the bottom. So that's the shortcut, how you get rid of radicals off the bottom. Move it to the top, and then just leave the radical sign off the bottom. Okay, that's the exact answer. That's the answer I'm looking for. That was the whole point of this problem, was to find that simple answer. One of these two, I don't know which one you wanted. They're the same. The answer is positive, because you're in the fourth. I don't need to worry about it. If it was asking for a different trig function, then I'd be worried. Okay, questions. Now, the new thing today. This is one of the charts you're going to want to put on your actual property sheet. Okay? So I think those are pretty much the main ones. I don't know if I'll get to my last example today. We'll kind of see time-wise. We have plenty of time here. All right. We have a new chart today. Other than just calling it a unit circle, because I know you have a unit circle on your chart already. This is a newer one. Okay? This is a new chart that I'd like you to put. So somewhere on your property sheet, find a gap, find a blank spot, and I'd like you to put this chart. So what you're going to do, draw kind of a Cartesian coordinate plane kind of a thing, but I'd like you to draw a circle on it. Try to do the best you can to draw that circle, and then just leave it blank for right now. We'll fill it in here in a second.
What's this number supposed to be?
What? That one? That one we'll get back to that.
This number
Yeah, it's 5. Family will start with us. Jason, I'm gonna reach out and grab that pencil. Okay. Now, this unit circle chart. It's a new chart. I'm gonna call it the cosine sine chart. The cosine sine chart. Okay? So, I'll let you write that down here. We're going to fill in some numbers on this chart just to make sure. Cosine sine chart. And now, here's how I remember the chart. It's called cosine comma sine, right? Alphabetical order. That's just how I'm going to tell you. That's how I memorize this. Now, what I mean by this chart. This chart will help you figure out answers if your trig function, like sine or cosine, is asking for perfect numbers that are quadrantal angles. Not the, what is it, the 315 and the 45s and the 150s and the 130s, not those. I'm talking about, perfect angles that are right on the quadrant. So if your angle was 0 degrees, or 90 degrees, or 270,
That's
180. 270, and then back to 360. Now, I know that your unit circle you have right now does have those marked on there, but this is going to explain to you, because I know what we use that bigger one for is I usually use the bigger one that's on that graph for the weird angles, like 45s and 60s and other things like that. But this chart is more or less focused on just these angles only these. So what I like to do is put dots right where your circle actually hit the axes. Okay, because that's where the angle would be, right? So do the best you can to draw that circle. I know I did a terrible job of drawing that. All right, now, if this is a true unit circle, okay, that means your distances from the origin out to one of those dots is going to be 1 in length. That's what a true unit circle is. It's 1 in length, 1 unit long. Okay.
Can you write that down?
If you want, yeah, you can put it off like in the middle if you want. Now, if that is truly 1 unit length, what is the coordinate on the coordinate plane right there? If it's 1 over.
1, 0.
1, 0. Does everyone agree with that? Okay, that is the correct coordinate if it was exactly 1 over. What about this spot?
0, 1.
0, 1. 0, 1, right? That's the exact spot, 0 right and left, up 1. What about this spot over here?
Negative 1,
1, 0. And this spot?
0,
0, 1, negative 1.
Negative 1. Okay. What you're looking at is the answers for cosine and sine at those angles. What you just did there. Those are the actual answers. So what I mean by that, if I went to 0 degrees, okay, I'm doing cosine of 0 degrees, right? This is the order they're written in. So when you look at your coordinate that's sitting there, what's the coordinate sitting at 0 degrees? 1, 0, right? That's the coordinate that's sitting there. Cosine is the front one. So what's your answer?
1.
1. That's what we'll give you on the calculator. If it wanted the sine of 0 degrees, sine is the back answer. 0. That's the exact answer what you'd get at those spots because of the way that those fall. Cosine is the first number, sine is the second one in the coordinate. That's the answer for that angle at that spot. So now if you're going up to 90 degrees, so if you're going to 90 degrees, well, the coordinate now, where we're at 90 degrees is 0, 1. So cosine of 90 is 0, sine will be 1. Do you see how the coordinates work now? How you use the coordinate to figure out the answer? Now there is one more chart we're going to get. We're not going to get it today. We have one more unit circle chart that will be for tangent and cotangent. But this, I know that some of these coordinates are on that circle there, but I only use this one. I can usually set this one up by myself off to the side on like a test because it's just using 1 unit length. So if I just memorize the coordinates, because you already know how to set up a coordinate plane, you know, to put dots exactly one across, 1 up, 1 over from the origin, you have all the answers. You just have to remember it's cosine first, sine second, because it's in alphabetical order.
Ugh,
So,
it's already on.
yeah, I know. I always set this chart up off to the side, because this is the one that I only use for zeros, nines. I know it's on the big circle chart.
Okay.
Yeah. Now, this is the reason why I brought this one up. Is because this explains why answers on your calculator are the way they are. What I mean by that is if you were doing a weird angle, not 0, not 90. Let's say we were doing a 30-degree angle, and I think somebody asked me earlier the week, why are you getting weird decimals when you type it in? Let's say I was doing a weird 30-degree angle. Okay? That dot lands right here. Okay? Agreed? On the unit circle? Well, is it exactly 1 over? It's not. It's actually short. It's actually going over to this point. It's not quite 1 unit over. So, and then going up, it's not quite 1 going up. 1 is up here. It's stopped short, right? It's not quite 1 unit tall. So, by guesstimating where that spot is, that's the numbers your calculator gives you. So what I mean by that, the x number. Now let's say that's like 0.8. Okay, let's just say it's 0.8. Going up, maybe that's 0.4. This spot, let's say it's 0.4 going up. It's not. It doesn't look like it's halfway between 1 and 0. It's kind of like a little bit lower than that. So just by guessing these numbers, this is the x number. This is the y number, 0.4. that would be your answer for cosine and sine at 30 degrees, roughly. I can guesstimate it by just looking at that chart. I can guesstimate the decimals your calculator would give you. So type it in. Type in cosine of 30. I think it might actually give you 0.86 or something, maybe?
0.866.
Okay, so 0.8. Okay, when you type in sine of 30, it might tell you a number really close to 0.4. It might even tell you 0.5. 0.5? So it was almost half. So my drawing was actually pretty accurate. This is actually the perfect halfway point where I actually drew that. So this was actually 0.5. But by just guessing this, I can actually get what a decimal is. So this is something that you can do on like a college level entry exam, like an ACT or a college math entrance exam, like Iowa State's engineering program. You can guesstimate decimals, and it's actually fairly accurate by doing that. And you can guess which answer on the A, B, C, or D makes the most sense. Which one gives you the closest answer? Boom, it's this one. Done. And it took me 3 seconds to draw that picture, to figure out, what I'm trying to figure out. It's pretty cool, but you just have to remember, you're guesstimating and you're using a unit circle. And so you're just figuring out roughly what the X and Y coordinate would be. And you're just guessing at it. But you have to draw the angle correctly. So you have to draw 30 degrees somewhat correct, and 45 and 60. Just kind of keep that in mind. Okay, questions with that? Okay, that's it for today. That's all I want to cover. So, now I did say that there was other unit circles, but we're not going to get those today. And those are not on that sheet. I know this one was, but it's kind of handy if you have this one off to the side.
When you were setting up the band, I asked,
Have you ever been to PreCalculus?
finish what, the chapter?
Actually, I'm usually
Well, because she was supposed to set